So today we're going to be looking at unit. So today we're going to be looking at Unit 3 review. Unit 3 was all about triangle congruencies and triangles. So, first up is some proofs. Number 1. Remember, for proofs, we have a statement column and a reason column. Number 1 says given point B is the midpoint of segment AE and B is the midpoint of segment CD, prove that the triangles are congruent. So remember, with triangle proofs, we're always going to assume we have to say the triangles are congruent, then check to see if we have to go farther. So we'll start off this proof by giving our first given. So B is the midpoint of AE. And then check. Our vocab word for our first given is midpoint. So I know my next reason has to be definition of midpoint. So midpoint splits the segment in half. So the half of AB would be AB is congruent with EB. We said a triangle congruency, so I'm going to mark it on my diagram. I'll write my next given. So B is the midpoint of CD. And once again, we have a vocab word of midpoint. So my fourth reason will be definition of midpoint. So if B splits CD in half, our two halves would be DE is congruent to CB. And I will mark this one as well. We're out of givens, we're out of vocab, so I'm going to refer back to my triangle look for list. First question, does it look like a bow tie? Well, in this case it does. Well, I know I have vertical angles. Well, my vertical angles then would be angle ABD is congruent to angle EBC. We have our three triangle congruencies. So I will say the triangles are congruent. Now there was a typo in our proof statement. It's supposed to be triangle ABD for the first one. So triangle ABD is congruent to triangle EBC. Looking at our triangle, I see we have two sides that are congruent, so I'm going to call this side, angle, side. Number 2, our given says diagram. Remember, whenever our given says a diagram, we look at the diagram and see what is marked congruent. So for example, I notice that angle A is congruent with angle D. I also know EB is congruent with side CB. So I'm going to refer back to my triangle congruency list. Or not the triangle congruency list, the triangle look-fors. First question, does it look like a bow tie? Yes, it certainly does. So that means we have vertical angles. Our vertical angles would be angle ABE is congruent to angle DBC. We have three triangle congruencies, so I can say triangle ABE is congruent to triangle DBC. Looking at our problem, we have two angles that are marked congruent on one side. If we go from one angle to the other, I don't cross a side that is marked congruent, so it has to be angle, angle, side. Moving on to example 3. Another given the diagram. So I'm going to look at the diagram and see what is marked congruent. So I know AB is congruent with CD. I also know that BC is congruent with DA. That is all that is marked congruent. So going through our triangle look-for list, question number 1, does it look like a bow tie? This problem, it does not. So question number 2, do they share a side? Yes, they do. So we know we have our reflexive property of congruence. So the side that they share is AC. So AC is congruent to itself. And I will mark that. We have enough info to say the triangles are congruent. So I can say triangle ABC is congruent to triangle CDA. Looking at this problem, I don't see any angles marked congruent, so this has to be side, side, side. Looking at our given statement, our proof statement, it says prove those angles are congruent. So we have to go a step farther. So I know my next reason has to be CPCTC. So I can say angle BAC is congruent to angle DCA. Number 4, for A, says write a congruent statement and list all corresponding parts. So this is the one where we have to name all of the angles that are congruent, all of the sides that are congruent. And then remember, the congruency statement is stating the two triangles are congruent. So sometimes it's easier to start off with just the angles. So I know angle S has one congruency mark, matches with angle B. I know angle R has two congruency marks, so it matches with angle C. I also know angle T has three congruency marks, so it matches with angle A. So those are our angles for the sides. SR has 3 ticks, so that has to match. So segment SR has to match BC, which also has 3 ticks. Remember, we have to go in the same order as our first one. I know RT has one tick mark matches with CA with one tick mark. I also know TS has two tick marks, so that has to match with AD. Now for our triangle congruency or our congruence statement. Triangle SRT is congruent with triangle BCA. Now for the problems where we give you a congruency statement and you have to tell us the congruent parts, remember the order that we write these in are congruent. So Q matches with W, R matches with X, S matches with Y. So when we ask for segment SR, SR matches with YX. Angle R matches with angle X. Number 5 says prove perpendicular bisector theorem, meaning we cannot use that theorem in its own proof. However, I'm just going to assume that this is a normal triangle proof. We're trying to prove triangles are congruent. So I will write our given statement, which says CD is a perpendicular bisector of AB. Given. Well, that has two vocab words. The first vocab word that it says is perpendicular, so I know my next reason has to be definition of perpendicular. Well, perpendicular, remember, means two lines or line segments that make right angles. So I know angle ADC and angle BDC are right angles. Well, we still have a vocab word in that. Our vocab word is right angles, and both of them are right angles. So I know I have to use the right angle congruence, meaning angle ADC is congruent with angle BDC. And I will mark those on our diagram. Well, we had another vocab word of bisector. So I know my next reason has to be dealing with that. So a definition of bisect. And remember, bisect means to split in half. And it's saying CD splits AB in half. So I know that AD is congruent with BD. Now I'll mark those. Well, we need to go through our triangle look for list. First question, does it look like a bow tie? Does it? So on to question 2. Question 2, do they share a side? In this case, they do. So I know I have our reflexive property of congruence. So CD is congruent with CD. And I'll mark that. Now, fortunately, we have enough information to say the two triangles are congruent. So I can say triangle ADC is congruent to triangle BDC. And we have two sides that are marked congruent, so this has to be side angle side. Looking at our proof statement, our proof does not say the triangles are congruent, so we have to move on. So I know my next reason has to be CPCTC. But this is a congruency statement according to CPCTC. So I have to write a congruency statement for our statements. So CA is congruent to CB. Now, unfortunately, that is not what our proof statement says. It says CA is equal to CB. So we do need to go one single step further, and we can change a congruent statement to be an equal statement because of the definition of congruence. Six says prove the base angles theorem, meaning we cannot use the base angle theorem in this proof, but we're going to do this as normal. We're going to assume that this is just a normal triangle proof. We're proving the triangles are congruent. So we have two givens. First given, KB bisects AC. Well, that has a vocab word, so I know my next reason has to be definition of bisect. So it says KB splits AC in half, so AB is congruent with CB. And I will mark that. We have another given, so AK is congruent with CK. And I'll mark that. Now, unfortunately, we don't have any more givens, so trying to look for. First question, does it look like a bow tie? Does not in this case. Second question, do they share a side? They do. So I know we have our reflexive property of congruence. So the side that they share is BK. So I know BK is congruent with BK. And I'll mark that. We have three parts of the triangle congruent. So I can say the triangles are congruent. So I can say triangle ABK is congruent to triangle CBK. Now looking at it, I have three sides that are marked congruent, so it is side, side, side. Now, looking at our proof statement, we need to go a step farther. So I have to say angle A congruent with angle C. And remember, if we ever go a step farther after saying triangles are congruent, it is CPCTC. And unlike number 5, we don't have to say they're equal. So we are done with this problem. Number 7, two parts, A and B. Find the value of x. So in A, we have x as an angle, 8x as an angle, and that box as an angle. Well, I know all three angles of a triangle add to 180. So I know x plus 8x plus 90, that box, equals 180. Combine like terms, so 9x plus 90 equals 180. Subtract 90 from both sides. And we get 9x equal to 90. Divide both sides by 9. x equals 10. B is our exterior angle sum theorem. It is our exterior angle equals our two far interior added together. In other words, 5x minus 2 equals 2x plus 76. We have an x on both sides, so I'll subtract the smaller, so minus 2x from both sides. So 3x minus 2 equals 76. Add 2 to both sides, so 3x equals 78. Divide both sides by 3. X equals 26. Question 8. This is our mid-segment problem. It says points A, B, and C are midpoints of the sides for that triangle. So before I go any farther, I'm going to mark that. I know A is the midpoint of QR, so both of those have to be congruent. I know B is the midpoint of SR, so both of these have to be congruent. And I know C is the midpoint of QS, so these have to be congruent. It says if SB is 2.5x plus 2, and CA is 3x minus 1, find SR. So by the mid-segment theorem, I know that CA equals half of SR. So I kind of want to know what CA is. So CA equals half of the full length of SR. Well, we kind of know what the half of SR is. That would be SB, which according to the problem is 2.5x plus 2. So we can use that to make an equation. So 3x minus 1 has to equal half of SR, or in this case, 2.5x plus 2. Now, just because this has a decimal, don't freak out. I'll get rid of the smaller one. So we have 0.5x minus 1 equals 2. Or, well, then we're going to add 1 to both sides. So 0.5x equals 3. Remember, 0.5 is just 1/2. To get rid of 1/2, we're going to actually either divide both sides by 1/2 or make life easier, times both sides by 2. So x equals 6. So going back, we know that CA is half of SR, so let's find CA first. So CA equals 3 times 6 minus 1. 3 times 6 is 18, minus 1 is 17. Now like I said before, CA is half of SR, so we need to double CA to get SR. So in this case, 2 times 17. So SR has to equal 34. Now this is proving our mid-segment theorem. So remember, to do this mid-segment theorem, we're not going to really do a two-column proof. Kind of do a paragraph proof. All that a paragraph proof, remember, is us saying these two things are congruent or proving that using sentences. We don't have to follow the whole entire rules of writing a paragraph of 3 to 5 sentences. It's just meaning using words. So there are two things we need to show. We need to show DE is parallel to AB, and we need to show the length of DE is half of AB. Does not matter which one we do first. So let's deal with these parallel first, meaning we need to know slope. So let's do DE first. Slope from a graph is rise over run. So going from D to E. Rise, we don't get up or down. So 0 over, well, how far we go. Be careful. Our x-axis, we're counting by 2's. So each of these solid lines are actually 2. So 2, 4. So our slope for DE is 0 over 4, which we can simplify down into just 0. Slope for AB. So we're going from A all the way over to B. Once again, we're not rising at all. So 0 over, we run over 8. This can be simplified down into 0. So then we need to write a sentence summing up what this means. So since DE and AB have the same slope, DE is parallel with AB. Because parallel means they have the same slope. So we have the first part of this proof done. The second part, we need to show the lengths are that DE is half of AB. So DE, well, going from point D to point E, we go over 4. For AB, going from point A to point B, we go over 8. DE is half of AB, so we can say that. So DE is half of AB.